Alright guys, welcome to lesson 1.12. We're almost there at the end of unit 1. Got one more after this. We're going to talk about inverses today. This lesson's funny. You're going to see this question throughout the year, like you will see all of these things throughout the year. But the thing about this one is that this one as a rule is really hard to remember for some reason. It's just And the reason why is because the formula looks really ugly for this derivative. So it's hard to remember, and you don't see it a lot, but it does pop up like once or twice a month. And when it does, it's kind of like, oh no, not that one again. So, I don't know. Put it on a flashcard and really try to memorize the rule to make life a little bit easier. But we're going to talk about how to find the derivative of an inverse function today. So the first thing we need to do is we need to review what an inverse even is. After that, we're going to observe the graphical relationship of the slopes of inverse functions. So, in other words, if you compare a function to its inverse, their slopes have a very interesting relationship to each other, and that's what we're going to look at. After we've kind of laid all that groundwork for what an inverse is and what their slopes look like, we'll be ready to dive into the calculus and talk about the derivatives of inverses, because after all, derivatives are slopes. So that's going to be our first order of business there. So first of all, let's review what inverses are. Okay. Two functions f and g are inverses if f of a equals b when g of b equals a. Okay. So let me give you guys an example of two functions that are actually inverses of each other. Y equals x cubed. Actually, instead of y, I think I'll stick with f. We'll use the function notation. So f of x equals x cubed, and g of x is equal to the cube root of x. These are inverse functions, and here's why. Because if I were to plug in, I don't know, let's say 2, to the f function here, 2 to the third power is going to give me 8. Whereas for this one, if I were to plug in 8, taking the cube root of 8, I would get 2. And you can see the relationships here. So what an inverse function is, it's a function where the input of this function is the output of the other and vice versa. Okay, that's what an inverse function is. And you can also kind of tell, it's a little bit hard sometimes, but you can kind of tell by the operations too. Like a third power is the opposite of a third root. Okay, it could get a little more complicated than that, but there it is. That's what two inverse functions are. Now, whenever you find two functions that are inverses, like this example I gave you here of f and g, clean up a little bit there. Instead of calling the other one g, then, we could call it f with a little -1, meaning inverse. That way, we know that they're related to each other. We know that they're inverses of each other. Or, instead of calling that one f inverse of x, I could have called the one on top g inverse of x. So, the point is that if they're inverses, this is the notation that we can use to show that they're inverses. You don't have to. You could really just name them as two separate functions, because they really are two separate functions. But it's kind of nice to have this situation, because then you know how they're related. They're inverses of each other. And sometimes it's not really so obvious that they are. Now here's a really interesting thing about the graph of inverse functions, right? So remember when I had f and g? Well, for f, when I plugged in 2, I got 8. And for g, when I plugged in 8, I got 2. Now, if you were to graph the point 2, 8 and the graph 8, 2, it would look something like this graph here. And this is how inverses work. They're always going to be like a reflection in this dotted line here, this perfectly 45-degree angle line, which is the line y equals x, by the way. If you reflect across that dotted line, that's what they'll look like. So for instance, when you graph y equals x cubed, it looks something like this. But whenever you graph, y equals the cube root of x, it looks something, I'm going to try, this is kind of hard for me, I'm going to try to do it though. It looks something like that. I don't think I did that right. Did I? I don't know, maybe. But it basically just ends up looking like a reflection through that dotted line. That's how inverses work. So if this is the graph of y equals x cubed, this would be the graph of y equals the cube root of x. And that's because they're inverses of each other, so there'll be a reflection through that diagonal line. That's how all inverses look when you graph them together. So we know what inverses are now, and we also understand what they look like graphically. All right, but let's talk about their slopes a little bit. So we talked about what inverses are. We know what their graphs look like. We understand the notation, but what about their slopes? Because their slopes also have a relationship, and that's going to be particularly interesting to us in calculus, because in calculus we care about slope. We call slope a derivative, and therefore it's really quite relevant to us. So let's say that I have a function f of x, okay? And for that function, when I plug in 1 for x, I get 4. And when I plug in, let's say, 3 for x, I get 7. Okay? So I'm going to go ahead and plot those points really quick. So there's 1, 4, and then 3, 7. Now, let's go ahead and do the graph of f inverse, though. Now, for the graph of f inverse, it's going to have the same points, but they're going to be reversed. It's going to be 4, 1, and 7, 3, because that's what inverses do. Now I'm going to graph that. So I'm going to go over 4 and up 1, and then over 7 and up 3. So here we go. Over 4 up 1, over 7 up 3. And there we go. So those two graphs there would be inverses of each other. But let's talk about their slopes a little bit. Okay? So for the one on the right over there, the slope is going to be y2 minus y1 over x2 minus x1. It's 3 over 2. Now let's take a look at the slope of the inverse function over here. y2 minus y1 over x2 minus x1. Let's compare their slopes. This slope and this slope, how would you describe the relationship of those two functions there? Well, they're reciprocals of each other, right? And that makes total sense because the x's and y's switched. Now, when you do your slope formula, it's y over x. But if you're switching your x's and y's for the other one, it'll be kind of like x over y. So it makes sense that they would be reciprocals of each other because the slope gets flipped, okay? And so that's the relationship, at least that's part of the relationship of the slopes, is that they're reciprocals. But remember, that's just regular slope. We're talking about calculus here, and calculus has to do with instantaneous slopes, instantaneous rates of change. So there'll be another little thing that we have to look at as we do it. There it is. All right, so here it is. What we've already discovered about the slopes of inverse functions is that, okay, so let's say that this top red line here is f of x, right? So that means the slope at this point here, let's call this point AB, the slope at x equals a, let's say it's going to be, I'm just going to make up some letters here, m over n, okay? So the slope of f at x equals a is m over n. So what would the slope of this other line be over here? What would his slope be? Well, it's the reciprocal, right? It would be n over m. But there's something here's the other half of the story. Yes, they're reciprocals of each other. We've already established that. But here's the new part. When you're talking about instantaneous rates of change, they happen at a specific point. Okay? Now, what are the coordinates of this point down here? The coordinates of that point would have to be reversed of that one. So it would have to be b comma a, and therefore we would be finding the instantaneous rate of change at x equals b. Okay? So the other half of the story is this. Yes, their slopes are reciprocals of each other. Their slopes are reciprocals of each other, but at different points, right? For this one, it's at A, but at this one, it's at B. Okay? So there's the big aha. Now, you guys might also notice when I wrote my derivative over here for f inverse prime, you put the little -1 and the f in their own little set of parentheses, because if you don't, it looks like this, and it could be kind of confusing looking in some cases if you left it like that. Like having these two things together, maybe it'll look like a -11 or something, and it's not, right? It's a f inverse prime. All right, so we write it like that. So in summary, let's summarize again really quick. Inverse functions work like this. If AB is on the f function, then BA will be on the inverse function. Their slopes are inverses, or not inverses, their slopes are reciprocals of each other, but at different points. Okay? So whatever this function's slope is at A, this function will have the reciprocal slope of that at B. Okay? So there's two differences, what x value you're looking at and also the fact that the slopes are reciprocals. All right, so that is the inverse function rule. So knowing all of that, let's go ahead and we're gonna do some problems here. So I'm gonna do example 1A, and then after that I'll give you guys a chance to think of your way through some of these things. Okay? So I've got over here a graph of f, and I've got a graph of its inverse there. You can ignore the dotted line, the green dotted line, if you want to. I just had that there because that's that invisible line that they're being reflected through because they're inverses of each other. But let's take a look at part A. Now, this is saying f of what equals what? Well, this would be an x value, this would be a y value. So what x value and y value did I give you on the f graph? I gave you f of 3 equals 7. Right? That was this point right here. Now, if f of 3 equals 7, then f inverse of what equals what? It would be 7, 3. And that would be this point right here, which I haven't labeled yet, but I will now. They're reversed, right? So that's just a property of inverses. There's no calculus there. All right? Now, before you can do part C, I have to tell you something about A. I don't know if I did this or not. Let me see. And yes, I did remember to do this. My numbers got off balance. There we go. Okay. So I drew a tangent line here at the point 3, 7 on the f function. And then I told you that, well, at least I wrote up here that the derivative of f at x equals 3 is 4. Okay? Well, because of that, I know what the slope of this function is at this point. Okay? And so that happens at x equals 7, so it's going to be f inverse prime of 7. And I know that the slope of this pink line should be the reciprocal of this blue line. So the reciprocal of 4 is 1/4. Okay? So if you know the slope of your original function, then you just take the reciprocal of that value to find the slope of your inverse function, but you also have to pay attention to the x values. For this one, it's at x equals 3, and this one's at x equals 7. Okay? So let's have you guys give some of these things a shot. So up here we have the red line is the graph of f of x. I've given you the point 6,3, which is on the graph of f of x. I've told you the slope of f at x equals 6 is 1/5. So your job is to fill in these blanks over here with as much information as you can. Okay, pause the video, and when you're done, I'll have the solution up. All right, so f of 6 equals 3, therefore f inverse of 3 equals 6. And since f prime of 6 equals 1/5, f inverse prime of 3 will equal the reciprocal of 1/5, which is 5. All right, let's go ahead and try another one. Okay, so the red graph up there is the graph of f of x. And the blue graph down here is the graph of f inverse. Go ahead, and I've given you the point here, 2, 3.4. I've also told you the slope of f at 2 is 3/2. So go ahead and fill in as many of these blanks up here on this guided practice 1B as you can. Pause the video, and when you're done, you'll see the solution. Okay, there you go. Let's go ahead and see what's next. Okay, this problem is pretty much like the others. We have the red graph is f. We have the blue one is f inverse. I've given you the point 2,1 on f. And I've told you the slope of f at x equals 2. So I want you to fill in as many of these blanks as you can. And I think you guys are going to be able to fill this in okay without any problems at all. But I think I want to challenge you guys to do something else. You'll notice that on my blue graph here, I did not put the dot. I would encourage you guys to see if you can put the dot in the right place and draw the tangent line as well. Okay? So go ahead and pause the video, see what you can do, and then we'll go from there. And there you go. So hopefully you guys have got the idea here. So when it comes to functions and their inverses, the x's and y's are reversed, right? So that's what this shows. And when it comes to their slopes are reciprocals of each other, but at different values of x, okay? So that is the relationship between f and its inverse and their slopes. Okay, so that's the basic idea, but I'm about ready to give you guys a formula. And this formula is useful, but it's ugly. It's not very pretty. It's difficult to remember. So I want to, first of all, show you where the formula comes from, and then after that, we'll start using it. So first of all, let's start off with the understanding of this. If f of a equals b, then that means that f inverse of b equals a, right? Now, we've also talked about the fact that the slope of the inverse function, in other words, the derivative of the inverse function at b, is going to be the reciprocal of the f function, so the reciprocal of the slope of the f function at a, right? So I put 1 over f of a because it's a reciprocal, and it's a instead of b because remember they happen at different values, but the primes mean their slopes. So the slope of the inverse at b is the reciprocal of the original one at a, right? Now, here, so that's kind of ugly as is, right? But we're going to make it even a little bit uglier now, so check this out. Now you might ask, why would we want to do that? Well, like I said, this is what actually is going to make it more useful. since we have a b over here, it would be awfully nice if we had a b here instead of a, and we can if we make one little change. Since a equals f inverse of b, then I can write this. And now I've got a function. So now I have a formula that can help me find the derivative of f inverse at any point for that inverse function. And so there it is. It's a really ugly looking formula. But and honestly, in the very beginning of my little math career here, I had trouble remembering it. But it's just something you kind of got to put on a flashcard and try to remember. I'm going to show you guys something else, and it might confuse you. So if you don't like it, then throw it away and don't use it. But so for myself, I had trouble remembering this formula, but I remembered something very interesting about inverses. If you take a function, and you plug into that function its inverse, right? Well, since these are opposites, they cancel each other out, and you're just left with x. Okay? So when you plug a inverse function into the original function, you're just left with x. Now, I want to show you guys something kind of interesting. So I had trouble remembering the formula, but I knew this because it just made sense to me. I knew that these are opposites, so they cancel, so you just get x. And that's all I ever took the time to memorize. But you can actually figure out the formula for the derivative of the inverse using this. Let me show you. If you take the derivative of this with respect to x, you can apply the chain rule. Derivative of the outside times the derivative of the inside. And then the derivative of x is 1. Now, I want to know what's the derivative of the inverse, so I'm going to divide both sides by this piece, which I'll highlight in pink so you know what I'm talking about. I'm going to divide both sides by that. And now I know that the derivative of the inverse is equal to 1 over f prime f inverse of x. So since I knew this, I just took the derivative of that using the chain rule and always solved for what I wanted. And I didn't have to memorize this ugly looking thing. But I don't know, if this isn't obvious to you up here, then that probably wouldn't help you. But there it is. So that is our little formula for the derivative of the inverse. And I think what's hard about it is the fact that I just have trouble. I remember all of it, except I just can't remember, does the prime go here or does the -1 go? I get those switched. And if you get them backwards, you will get it wrong. So you got to make sure you have the order of those things right. But anyway, this is the formula for the derivative of an inverse. Okay, so this is that. All right, so knowing all that, let's go ahead and get down to business here. Before I actually start these problems, though, I want to test your guys' knowledge a little bit, okay? So, for instance, what is f of 2? What is f of 2? Well, I hope by now you guys know it's 3, right? Shouldn't be a problem. Now, what is f inverse of 3? So if I gave you guys this, well, I just gave you the answer, darn it. But what is f inverse of 3? Well, it would have to be 2, right? Because these are switched. But how can we do it from here? Well, what you have to remember is that this number here is going to be in the f of x column, and this answer that you get is going to be in the x column. So if I give you an inverse expression on a table like this, the number in the parentheses is going to be in the f column. So I would look for where f of x equals 3, and my answer would be the 2. So it's like working backwards. Usually, we start at x equals 2, and then we look for what the f function is under that, right? But in this case, the number that they give you, you're going to look for in the f of x column, and you're going to put your answer as the x. And the reason for that reversal is because they're inverses. So let's do another one really quick here. Let's say, what is g inverse of 1? What is, I don't like that question. What is g inverse of, I'll do f, because I don't like the way these ones turned out. Let's do f inverse. What is f inverse of, I guess they're all like that, 2. What's f inverse of 2? So what you're going to do then is you're going to look for 2, but you're not going to look for 2 in the x column like we used to. You're going to look for 2 in the f column, and the answer will be the x value that comes out of it. Okay, so that's how you can evaluate those. So I'll throw one more at you guys. How about this? What is g inverse of 3? What is g inverse of 3? So you'd start by looking for 3 in the g column, and then the answer will be the x value that goes with it, which actually is 3 also. So that's how you can find the answers for functions like that on a table. All right, so let's get down to business. So we need to find g inverse of 2. Well, first of all, the first thing you're going to do is you're going to write your formula out. That nasty formula that you don't want to have to memorize. So, g inverse prime of x is equal to 1 over g prime of g inverse of x. Okay? After that, you're going to plug in the value that they give you. So in this case, they want us to do 2, so I'm going to plug in 2. Okay, now we get to simplify. So here we go. The first thing you're going to simplify is this. What is g inverse of 2? Ponder that for a moment. What is g inverse of 2? G inverse of 2, that means I'm going to start in the g column, I'm going to look for where it says 2, and I'm going to give the x value that goes with it, which is 1. But we're still not done. Now we need to do what is 1 over g prime of 1. And well, actually, I just need to find what's g prime of 1, right? So what is g prime of 1? Now this is normal. This is not an inverse, right? So that means that this is now an x value once again. We're going to start where x equals 1. Let me erase some stuff here. We're going to start where x equals 1, and we're going to go to where the g prime is now. And so the answer is -1. So remember, when you're doing an inverse, you start in the g column, but when you're doing a regular function, you start in the x column, right? And so the final answer there is -1. All right, so formula, plug in, simplify. Let's do another one here. What would the formula be for this? That's the first thing we need to do. We need to do the formula. So there's the formula for the derivative of f inverse. Next, we need to plug in 3. Oops. F inverse of 3. What is f inverse of 3? Hopefully you know that it is 2. What is f prime of 2? F prime of 2 is a half. So I've got 1 over a half. And now for this one, we need to simplify it, which we've talked about before. You multiply by the reciprocal there, so the 2's cancel. But whatever you do to the bottom, you do to the top. And so we end up with 2 as our final answer. Okay? So, how about you guys give it a try? Go ahead and pause the video and see if you guys can get these two derivatives. I'm a little disappointed in these answers. They come out to be the same answers we got on the last one, just by coincidence. Sometimes the software I use to make these problems is not very creative. But the answer number 1, as you can see, is -1. And the answer number 2 is 2. All right, so that is that. All right, let's take a look at another type of example here. So instead of working with tables now, we're going to do a similar thing. We're just going to be doing it with equations instead of tables this time. All right. Okay. So let's go ahead and look at what we're given here. So I have this function f of x, and I'm giving you a new function called g, and it's the inverse of f. That's what g equals f inverse of x means. So in other words, g is the inverse of x. That's what that little statement means. And f of -1 equals -6. Now, as you guys know, if f of -1 equals -6, then that means that the inverse of f of -6 would have to be -1. Another way you could write that, since f inverse is g, is you could write it like this. Okay, either way is fine, but there it is. So now our goal is to find g prime of -6. Another way to write that is f inverse prime of -6. I find it, a little irritating myself. Why don't they just call it one thing so we don't have these two different names up here? Well, I don't know. It's just how problems are sometimes. So just be aware that you can call it either f inverse or g. Or you can call it g prime or f inverse prime, but they're the same thing, okay? So there's some preliminary work, just kind of paying attention to those things. Now, since I'm looking for f inverse prime of x, let's write out our formula. F inverse prime of -6, right? That would be 1 over f prime of f inverse of -6, right? Now, so here's my advice to you guys on these. Step 1, I would do what I've done here. I would just rewrite everything with f inverse. Step 2, I would write out your formula. And then step 3 is to start simplifying it. So 1 over f prime of, well, what is f inverse of -6? We wrote it right here. F inverse of -6 is -1. So I can replace the f inverse of -6 with -1. And now here's where things get a little bit different than the table, okay? So far it hasn't really been all that different. It's presented differently, so they use different names. That was weird. Formula's the same, though, and just plugging stuff in. But here's where things get a little bit different. We don't have f prime of -1 anywhere. They didn't give that to us. But what they did give us is the function. And if we have the function, then we can find the derivative and plug in 1. So let's find the derivative of f. The derivative of f is going to be 2x plus 4. That's this thing, right? And now, since I want to find f prime of -1, I'm going to plug in -1 to the derivative. So I get 2. And so since f prime of 1 is negative 2, I can replace f prime of negative 1 with 2, and we have our answer. So we're all done. All right, so step 1, rewrite your information. If f is this, then the inverse is this, which can be rewritten as a g because apparently they're the same. And also I chose to rewrite my derivative of g as a derivative of the inverse of f since they're the same. And then step 2, I went ahead and came up here and then I wrote out my formula. Step 3, I replaced the f inverse of negative 6 with negative 1, and I got that from right here. Step 4, since I want f prime of negative 1, I found f prime and plugged in negative 1. Step 5 is your answer. Just take that last thing and put it in the bottom, you're good to go. So that's that. Now another way you can think about this is in the following way, but if this is making your brain twist in 20 different directions, this might be overwhelming for you, but it's quicker if you understand it. So here's what I know. I know that g is the inverse of f. I know they want me to find the slope of g at negative 6. I know that since g is the inverse of f, that the slope of g at negative 6 will be the reciprocal of the slope of f at negative 1. So all I would do is, a faster way to do this is to find the derivative, and instead of plugging in negative 6, just plug in negative 1. And just remember, since it's the inverse, we're flipping it over. Okay? It's a little bit more difficult to understand and follow, but there it is. That's a faster way to do it, but do it however you please. So here's one for you guys. Go ahead and pause the video and see what you guys get. Okay, so step 1, I rewrote my information. Since f of 1 equals negative 5, that means that f inverse of negative 5 is 1, or you could say g of negative 5 equals 1, since g and f inverse are the same thing. And then I also reinterpreted what I'm trying to find. G prime of negative 5 is the same thing as f inverse prime of negative 5. Now I jump off from here into step 2 using my formula. F inverse prime of negative 5 would be this expression here. F inverse of negative 5, as we said over here, is 1, so I can replace that with 1. Step 4, we need to find f prime of 1, so I find f prime, and then I plug in 1 and I get negative 2. So all I need to do now is replace that with negative 2, and we have our final answer, negative 1/2. Alright, once again, another way to do it is to say, okay, well I know that g is the inverse of f. And since I'm trying to find the slope of g at negative 5, that's going to be the reciprocal of the slope of f at 1. So I would just do 1 over f prime of 1. And after I calculate f prime of 1, I got my answer. So there you guys go. All right. And that does it for our lesson today. Until next time.